Matt, sometimes I just need you to shut up. All right, let's start.
I've got hurt feelings. I've got hurt feelings.
Which of the following should be part of solving any problem in physics? Select all that apply.
Read the problem carefully? No. I think you should read the problem recklessly.
Danger's my middle name.
Just kidding.
Matt, I don't think that's appropriate for our audience.
Okay, sorry everybody. I have to say that yes, you should read the problem carefully because if you don't, you might miss something important. So I'm going to say that's important.
That's right. We don't joke around on this channel.
I'm a professional.
Draw a picture of the situation. That can be really helpful, especially if you're not provided with a figure or a document or whatever to help you map it out. So if you can draw it and that helps you keep track of the numbers and the directions and visuals, I'd say that applies too.
Nice. Yeah, I think that's one of my favorite strategies, actually. C. Write down the variables that are given.
Yeah, because every problem gives you a certain amount of variables. And if you write them down, it helps you figure out, well, what am I looking for that I don't have? And also, what's not given to me that I can use my knowledge to plug in? Because sometimes we only get a certain number of variables, but we need at least 3 to start the problem. And then I remember, we can apply the force of gravity, which is a fixed number, to solve this problem.
Yeah,
So
it's like
when
the
you write-
first step of turning it from a word problem to a math problem. It's kind of like, hey, these are all true. But, at this point, let's just roll with it.
It's true. All of it.
D. Think about which physics principles to apply.
Yeah, that goes with the force of gravity from before, where, I might not have all the variables here, but there are principles or just constants that can be applied to the problem in areas that don't seem obvious right away.
Right? Determine which equations can be used to apply the correct physics principles.
That's great. It's important to do this after you know what all your variables are, because then you can go through the equations that you know and pick which one is best to start solving the problem.
Nice. Check the units when you have completed your calculation.
Very true. I often give an answer without remembering to include meters or seconds, and technically the answer isn't complete unless you have your units.
Awesome. Finally, consider whether your answer is reasonable. What's that actually mean, though, to consider whether your answer is reasonable?
Along the way, you might have made a mistake, but if you look at the end and you see that the answer is negative when it's about something moving upward, or there's just something about it that doesn't track or make sense, then that will tell you to go back and look at every step you've taken to make sure that it's the right answer.
Right. If you've got a crawling caterpillar and it's moving 4,000 meters per second, you've probably got an issue.
Absolutely. Not that that's happened to me or anything.